The universe, once a blurry enigma beyond Earth's veil, now explodes with breathtaking clarity for all to witness. This dramatic shift in our cosmic vision irrevocably changed humanity's understanding of everything beyond our blue planet. For millennia, our ancestors gazed upward, mapping stars with naked eyes and rudimentary instruments. Early telescopes offered tantalizing glimpses, revealing lunar craters and Jupiter's majestic swirling moons. Yet, Earth's turbulent atmosphere remained a persistent, distorting barrier to truly clear astronomical observations. Imagine trying to read fine print through constantly rippling water, an apt analogy for early ground-based astronomy. Astronomers painstakingly pieced together fragmented data, often speculating about unseen cosmic structures. The dream of truly piercing the atmospheric curtain persisted, fueling generations of scientific ambition and innovation. Their instruments, though powerful, could never escape the blurring effect of atmospheric light pollution. This fundamental limitation meant much of the universe remained shrouded in frustrating, persistent mystery. Stars dying, unobstructed view TS planets, evolving with unprecedented, a direct window into the deep, enigmatic cosmic tapestry.
We yearn to see galaxies forming, stars dying, and planets evolving with unprecedented, vibrant detail.
The audacious idea emerged: place a telescope above Earth's atmosphere, far from its distorting influence.
This ambitious concept promised an observatory offering crystal-clear images, unimpeded by atmospheric shimmer.
Scientists envisioned a giant eye in the sky, capable of capturing light across the electromagnetic spectrum. Developing such a complex instrument presented unprecedented engineering challenges and required immense dedication. Building optics with near-perfect precision and designing robust systems for space proved incredibly daunting. Funding battles raged for decades, testing the resolve of visionary scientists and engineering teams worldwide. Finally, after years of relentless effort and countless setbacks, the dream began taking tangible form. The launch itself was a monumental event, a testament to human ingenuity reaching for the heavens. But then something unexpected happened. Almost immediately after its deployment into the vastness of space, initial images transmitted back to Earth were disappointingly blurry, revealing a critical, heartbreaking flaw. A microscopic defect in the primary mirror, barely the width of a human hair, caused spherical aberration. This meant the telescope, designed for ultimate clarity, suffered from a fundamental, image-degrading imperfection. Public disappointment soared, and critics questioned the colossal investment in this seemingly failed project. The scientific community grappled with the profound implications of this very expensive, almost unusable instrument. Yet, astronomers refused to surrender their vision, devising an audacious and incredibly risky repair mission. They designed corrective optics, essentially cosmic contact lenses, to compensate for the mirror's precise error. Astronauts underwent rigorous training, preparing for an unprecedented in-orbit repair operation in zero gravity. This delicate mission represented a pivotal moment, a high-stakes gamble with the future of space astronomy. Imagine attempting intricate surgery on a multi-billion-dollar instrument, hurtling around Earth at thousands of miles per hour. The tension was palpable as the shuttle approached. Precise spacewalks.
Astronauts meticulously installed the corrective instruments, working through challenging, precise spacewalks. Every movement was critical, every bolt turned with the utmost care, watched by a captivated world below.
And then came the moment of truth, the first images after the daring, successful in-orbit repair. The transformation was instantaneous and utterly spectacular, exceeding everyone's most optimistic expectations. What was once a hazy smudge transformed into a vibrant, star-studded panorama, rich with intricate detail. The telescope, now fully operational, began delivering unparalleled views of distant galaxies and nebulae. This marked the definitive turning point in humanity's visual exploration of the cosmos, a true revelation. Suddenly, the universe presented itself in stunning, high definition, revealing previously hidden cosmic wonders. We could observe stellar nurseries, glowing with nascent stars and galaxies, colliding in slow, majestic dances.
These images unveiled intricate planetary nebulae, the dying breaths of stars, painted across the cosmic canvas.
The clarity allowed scientists to precisely measure distances and study the universe's expansion with new accuracy. The dying breaths of stars, its groundbreaking discoveries, redefined our understanding of cosmic evolution and galactic formations. The resolution, allowed astronomers to distinguish individual stars in distant galaxies, a truly astounding feat. It proved that humanity could overcome even the most formidable challenges to achieve unparalleled cosmic insight. These iconic images transcended scientific journals, inspiring millions around the globe with their sheer beauty. They became cultural touchstones, adorning classroom walls and igniting a passion for space exploration. Public engagement with astronomy soared as people witnessed the universe's grandeur firsthand through these images.
Scientists gained an entirely new perspective on cosmic phenomena, challenging long-held theories and assumptions. The data collected profoundly reshaped cosmology, offering insights into dark matter and dark energy's mysteries.
We learned about the extreme environments of black holes and the violent birth of new star systems. Precision than ever before energies possible. It revealed the startling diversity of galaxies, from majestic spirals to chaotic, irregular formations. This visual revolution fueled the development of subsequent, even more powerful space-based observatories. Each new image pushed the boundaries of human knowledge, revealing an ever more complex and beautiful cosmos. It provided compelling evidence for exoplanets, indicating the potential for life beyond our solar system. The sheer aesthetic appeal of these cosmic portraits made the universe accessible to everyone, not just experts. They fostered a sense of universal connection, reminding us of our tiny place within an immense, vibrant cosmos.
This turning point transformed abstract scientific concepts into tangible, awe-inspiring visual realities.
It demonstrated the profound value of investing in fundamental research and pushing technological boundaries, a testament to human-inspiring curiosity and our visual relentless drive to realities understand existence.
Future generations will continue building upon this legacy, exploring even deeper into the universe's secrets.
The quest for clearer, more profound cosmic understanding remains an ongoing, inspiring human endeavor. From blurry smudges to breathtaking cosmic masterpieces, space imagery's evolution undeniably reshaped our universe. This pivotal transformation continues inspiring discoveries, reminding us of the endless wonders awaiting our gaze. It stands as a testament to humanity's unyielding spirit of exploration and technological triumph over adversity. If you found this cosmic journey fascinating, subscribe for more incredible stories about science and discovery. And let us know in the comments what interstellar image captivates your imagination most of all.